interfacing applications. We will brief about this module. We are going to study the topics of 8051 interrupts. We already studied about interrupts. Here, with respect to timer and counters, we are going to discuss some of the programs in this module. And 8051 assembly language programming by making use of interrupts, we are going to study here to generate an external interrupt using a switch conditions we are going to discuss. And also we are going to study 8051 C programming to generate a square wave on a port pin using a timer interrupt. Okay, for the timer and counters we are going to use interrupts. We are going to write a C programs as well as assembly language programs also we are going to discuss in this module. And the second part of this module is interfacing of 8051 to ADC0804 analog to digital converter and DAC digital to analog converter and LCD stepper motor and their interfacing programs using assembly language program we are going to discuss here. Okay, this is the topics we are going to discuss in this module. And coming to the knowledge level, this is a CO 246.5 with respect to 8051 assembly language programs to generate a square wave on 8051. We are going to discuss about the interrupts and input output port pin using interrupt and C programming. We are going to send the data and receiving the serial data by making use of 8051 serial port. And also we are going to discuss the interrupt and interface and with respect to the program for ADC digital to analog to digital converter as well as analog digital to analog converter, LCD display, and how exactly stepper motor is going to interface with respect to 8051 with respect to the input output ports. This will be coming under knowledge level 3. It will be going to. Why? Because we are going to write up programs so that we are going to use some of the logic over here. That is why it will be under level 3. Okay, this is about your basic how exactly the module, 5th module, what is the knowledge level. Beyond this knowledge level, whatever the things we can discuss in this module will come to know when we are going to discuss about the topic. With respect to the 5th module, PPT is visible now?
Yes, sir.
Okay. Okay, here we have two parts, interrupt and interfacing. We'll discuss later interrupts, that is it requires only 1 or 2 hours. First we'll discuss about the interfacing, ADC, DAC and stepper motor, LCD we'll discuss first, then we'll discuss about the interrupts. Here we need to discuss about digital to analog converter. This is a basic introduction for DAC, and we have with respect to the block diagram how exactly we are going to get this equation. Those things we need to discuss. Okay, before going to study this, we'll discuss some of the introduction based on the conversions. Notepad is visible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay, interfacing. Of 8051. Why we need to interface 8051? What exactly the meaning of interfacing? Interfacing means we are going to connect an external device to your 8051. This is your 8051 microcontroller and this is your external device. For example, this will be your sensor. I'm going to take it as a sensor as an example. What type of sensor it is? Why we need to interface these two? For example, if you are a final year student, you want to do one project. What is that project? I am going to tell the aim of my project, means objective of my project is I am going to see the condition of a patient. Okay, I am going to observe the condition of a patient. Means, for example, in the hospital or else in the home itself. For example, in your home, some of your old age people, grandmother or grandfather is a old age people. We cannot observe him or her for 24/7. Okay, we need to get some of the data from this patient. Okay, he is staying in one room. Okay, we need to check every time his body temperature, and also room temperature, whether the light will be on or off, we need to check that also, that is radiation of a light. These things we need to observe. We cannot observe for 24/7. We are going for the office. From there we can track this data. For example, this is just example, a simple project. Okay, if I am going to get the data of a home or a room, anything which will be getting the data. 1 minute. Adarsha B. Adarsha. Adarsha. Okay, so that I am going to interface these devices, these temperature sensors, temperature sensor, light sensor, body temperature sensor. I am going to interface to 8051. Then from 8051, I am going to connect one GSM module. From that GSM module, I am going to get a message to my mobile. Like that, I am going to develop one project. Okay, for that I need to take this sensors. Sensor is in the form of analog data. Sensors are in the form of analog data. But our microcontroller will understand only digital data. That is why first of all I need to take my raw data of analog raw data. I need to convert this into digital. For that, I need to discuss about analog to digital converter. How exactly it will be going to convert an analog signal to digital signal. Then, for example, if I am going to convert this analog signal to digital signal, vice versa, I need to convert digital signal to analog. Why? Because we need to find the in the receiver, we need to get the signal that I am going to, vice versa, I need to find. Okay, so that, for example, if I am going to convert ADC, we have a 0809 IC we have. Okay, how exactly it will be working? For first, digital to analog converter. How exactly we are going to convert digital to analog? That will be 0808 IC. How exactly it will be working? These things we need to discuss. Okay, first and foremost, introduction to analog to digital and digital to analog converter we are going to discuss now. Okay, with respect to the block diagram, I am going to discuss all those things. Okay, this is the block diagram for analog to digital and digital to analog converter. Both in the same block diagram I am going to discuss here. Make a note of this. This is my analog input signal. Okay, after that I'm going to take anti-aliasing filter, sample and hold circuit. This is quantizer and encoder. This is my digital signal processing. This is my decoder. This is my reconstruction filter. This is my again analog output I'm going to get. Okay. The upper portion of this block diagram will discuss about your ADC, analog to digital converter. Then the lower portion of this block diagram will discuss about the digital to analog converter. Here I am going to get a digital data in the form of ones and zeros. Here again I am going to feed this ones and zeros to this digital to analog converter. I am going to convert that back into analog signal. Why I am going to discuss both? We have both ADC as well as DAC, DAC. We need to convert how analog to digital. Again, we need to convert digital to analog. Both will discuss in the same block diagram. Okay, for example, copied this block diagram.
2 minutes, sir.
Okay, right on.
Sir, what is the last block, sir?
Reconnection filter. This one now.
Yes, sir.
Reconstruction filter. Okay. What is analog signal? Analog input signal I am going to take. For example, this is my analog signal. It's a continuous signal. It will be vary with respect to time. This is your analog signal x of t with respect to time. It will be going to vary. See, for the block diagram, we are not taking an analog signal. We are taking analog signal, but it is not a sinusoidal signal. Okay, if I'm going to take the signal from signal generator, I'm not getting any noise. For example, I am going to take a data of a real-time data. When I am going to take a real-time data, for example, that is your light sensing. We are going to take a light sensor. From the light sensor I am going to take a light data or temperature sensor, whatever the data if I am going to take, that will be having some of the noise. It will be going to add with the noise. Okay, and even that signal is not a strengthened signal, it will be having a weak signal. So that here I am going to take it as a filter. Anti-aliasing means we are going to boost the signals, means it is like an amplifier, and we are going to filter all our noise. We are going to filter by make use of this filter. This is my analog signal. Next we have a next block is a sample and hold. What is the meaning of sample? Okay, whatever the signal we have, we are going to mark some of the points. Okay, I'm going to sample this signal. I'm going to sample this signal at particular instant of this time. What is the amplitude? And at particular time, what is amplitude? Like that, I am going to sample that signal. If I am going to sample, how I am going to get the signal? Sampled signal will be like this. I am going to get. This is my sampled signal. I'm going to sample the signal. Means I'm going to check the value at particular instant of time. This is for 0 second, 0 information. At 1 second, what is the data? At 2 second, what is the data? At 3 second, what is the data? That I'm going to divide by make use of a sampling theorem. Okay, here also we have a 3 conditions. Okay, message signal is equal to a carrier signal. FM is equal to FC or carrier signal, or FM is equal to 1 over 2 pi FM. It will be FM is greater than 2 FM. FM is less than 2 times of FM. FM is equal to 2 times of FM. Based on these conditions, it will be going to work with respect to your sampling theorem. Those in detail sampling theorem we are going to study it in the next semester. Principles of communication system. Like that, we are going to sample the signal. Okay, once if I am going to sample, by make use of sample and hold circuit, I am going to draw like this. I am going to draw like this. I am going to get a output like this. I am going to get the output like this. Then we are going to use a quantizer. Quantization, if I am going to use quantization means it will be going to find the step size. It will be going to find the step size like this. It will be going to find the step size. Okay, what we have a different types of quantization: mid-riser and mid-trade. Mid-riser quantization and mid-trade quantization. We have different types of quantization. Here we are going to use some linear quantizer technique we are going to use to find the step size. If I am going to find the step size, if it is, for example, if it is 2 power 2, it will be 4 possible cases: 0, 0, 0, 1, 1, 0, 1, 1. For example, if it is 0, if I am going to get a voltage level 1, it will be equated to 0, 1. If it is it will be amplitude of 3 volts, that will be equated to 1, 1. Like that, 0, 1. Initially it will be 0, 0, 0, 1, 1, 1. Again it will be decreasing 1, 0, 1, 1, 0, 0. Like that it will be going to convert the digital data. Okay, once if I am going to use quantizer and encoder, we are going to get a digital data in terms of 1 by 1, 0, 1, 0, 0, 1. Like that we are going to get a digital data. Okay, once if I am going to get a digital data, I can take this data by make use of IC 080 and 090. If I am going to use, I can interface with respect to the 8051, so that 8051 will be easily understand the logic of this digital data, so that we can interface the 8051. For example, now I am going to take 8051. Here I am going to take one IC, that is 0809. Here I am going to give an analog data that will be converted into digital. Then it will be going to give it to 8051. Again, I am going to display with respect to LCD display. I am going to get the so and so temperature. It will be going to display in that room. Like that, I am going to get the output. Okay, it is clear, analog to digital conversion. Then vice versa. Here we have a digital signal processing unit. It will be going to process the digital data, and here it will be decoder. It will be decode as quantizer and encoder. How exactly we are going to use that will be reverse position of that. It will be going to work, and it will be going to reconstruction the filter. It will be going to get the analog output once again. Okay, we are going to give analog signal here, digital data conversion. Again, if I am going to give digital data here, it will be going to get a analog signal. This is about your analog to digital and digital to analog conversion. Next, we are going to use digital to analog converter. I see how exactly it will be going to work. That we are going to discuss now. Okay, digital to analog converter, DAC 0808. DAC 0808. This is a IC. Okay, what are the features of this? We will discuss. The first point is it is a 8-bit current output monolithic DIC. It's a 8-bit current output digital to analog converter. Analog converter means analog output we are going to get in terms of current. That is why we are going to call it as a 8-bit current output DAC or monolithic DAC. Monolithic DAC we are going to call. These are the technical terms we are going to use when we are going to discuss the features of 800808. And it will be manufactured by, this is an IC, this is a 16 pin IC. Okay, we are going to deal with an 8-bit current output DAC, and it will be manufactured by National Semiconductor Corporation, NSC, National Semiconductor Corporation company will be manufacture these ICs, and this will be a 16 pin IC, 16 pin IC in dual-in package. It will be available in dual-in package, and it is having 8 input lines. It is having 8 input lines. If it is 8-bit, we need to give 8 inputs. Okay, that is why it will be 8 input lines. That is in the form of digital. Why? Because this is a digital to analog converter. We are going to get only one output. That is single output. That is in terms of current we are going to get. These are the features of 800808 IC. Make a note of this. Then we'll discuss the pin description of 0808. Okay, next we'll discuss about the pin diagram of 0808 ADC. Pin description or pin diagram. Pin description of 0808 analog to digital to analog converter DAC. This is 16 pin IC. 1, 2, 3, 4. Okay, this is a 16 pin IC, that is digital to analog converter 0808. Here we'll discuss one by one. Totally 16 pins we have. Pin number 1 will be no connection. We are not going to use this pin. Why? Because it will be keep it for the future purpose. And the pin number 2 is a ground pin. Whichever the IC we are going to use, it should be positive and negative voltage. We need to apply some of the voltage for the IC to work, so that we are going to give positive and negative voltage. This is a ground potential, that is a negative voltage we are going to give. Next we have VEE. We have a different voltages, that is VCC and VEE. VCC and ground will be with respect to working of an IC 0808, and VEE is some of the voltage externally we are going to give. Okay, next analog output pin number 4. Analog output pin number 4. This we can also take it as a I0. Okay, then pin number 5, pin number 6, 7, 8. Frequently it will be A1, A2, A3, A4. One minute. Okay, we'll continue. Pin number 5, 6, 7, 8. Frequently data A1, A2, A3, A4, and pin number 9 will be A5, A6, A7, A8. These are the digital data what we are going to give it to this IC. Okay, if it is output, we are going to get it in terms of current. This will be going to convert a digital data, that will be 8-bit data. We are going to give it from A1 to A8, or else if you want you can take A0 to A7 also. You can take. It is not mandatory to take A. You can take D0 to D7, D1 to D8, like that. Anything you can represent. Okay, here we need to identify the MSB and LSB. This is A1 will be MSB. This is the most significant bit, and this will be your LSB bit we are going to represent. And the pin number 13 will be a VCC. Any IC should be work. It should get a positive as well as a negative voltage. This is your VCC positive voltage, and this is a negative will be a ground potential. Next we have externally reference voltage. We need to apply some of the sometimes, so that V reference of positive and V reference of negative voltage we need to apply, and this is a compensation. This pin will be used for future purpose, that is compensation. We are going to call this pin. Okay, this is about your 16 pin 08 and 08 analog to digital, digital to analog converter. Here we can give 8 different digital lines or digital data we can give, that will be converted into a single output, that is an analog signal. For example, in the upper block diagram, I am talking about block diagram, in the upper side we have converted that into digital. That digital data, if I am going to give it to this IC, this will be converted back into your analog signal. What we gave it in the upper side input, that will be getting output as a in the lower side. This is about your IC 0808. Then how exact, if you know this pin diagram, pin configuration, then it will be easy to discuss in the further classes. Okay. Is it fine?
Yes, sir.
Copied everyone?
Yes, sir.
ನಟರಾಜ್ ಸರ್
ಸರ್
PPT ಡಿಸ್ಪ್ಲೇ ಮಾಡಿ ಸರ್.
ಸರ್ ನೋಟ್ ಪ್ಯಾಡ್ ಅಲ್ಲಿ ಬರಿತಾ ಇದ್ದೆ, ಇವಾಗ PPT ತಗೊಂತಾ ಇದ್ದೀನಿ ಸರ್.
ಏನೋ ಒಂದು ಡಿಸ್ಪ್ಲೇ ಮಾಡಿ. ಹೌ ಆರ್ ಯು?
Is it visible PPT?
Yes, sir.
visible.
Yes, sir.
Yeah, what we discussed so far, how exactly 08 digital to analog converter it will be work. These are the features of your digital to analog converter. Here we are going to use two different types of digital to analog converter. That is, first one is binary weighted resistor, and the second one is R to R ladder network we are going to use. Then what is the drawback? We are not going to use binary weighted resistor, means we are going to use some large values of a resistance values, so that sometimes in the practically we are not available with that resistor values. That is why we are preferably going for R to R ladder network. R to R ladder network in the sense we are going to use 1K and 2K resistor, that we can see here. in the circuit diagram. See here we are going to use R and 2R network we are going to use. Here we are going to get a good precision and accuracy we are going to get. That is why we are going to use R to R conversion we are going to use preferably. See what we discussed so far, digital to analog converter. You can take this. Here we are going to provide the current I output is a function of I reference with respect to D0 to D7. What I told D0 to D7 or A0 to A7, 8 different data inputs we are going to give it to your IC, that is your 0808 IC. Then we are going to interface with respect to the 8051 IC. Okay, so that what we need to do, we need to convert analog signal to a digital equivalent. Okay, make a note of this circuit diagram. Then we'll discuss how exactly we are going to convert our digital signal to an analog equivalent. Make a note of that.
सर ಸ್ವಲ್ಪ zoom in ಮಾಡಿ ಸರ್. Yes, sir.
You make a note of this first, then we'll discuss about that. Or
Yes, sir.
make a note of this diagram. This is how exactly we are going to interface with 8051 and 0808. See in the 0808 IC, no need to write the pin diagram, pin numbers. Whichever the pins you are going to use, that you can write. It's enough. Ground V analog output where you are going to get output. Then input lanes will be D0 to D7. Here it mentions mention the read and write. There is no read and write pin in the 0808. Don't confuse that. VE and compensation pin is there connected with the capacitor. Then after converting analog signal, we need to amplify that signal. Okay, why? Because it will be in the lower voltage, so that we need to boost the energy of that signal. We are going to use one operational amplifier to increase the strength of that signal. We are going to get a large output. The output will be vary from 0 to 10 volts. See, this equation we are going to get with respect to R to R ladder. If I am going to solve the network of R to R ladder, that much in depth you don't have in the syllabus. Just you have to know the relation, how exactly we are going to get. If you want, I have the solution. I will share with you people. Okay, you can go through once. Or else in the next semester you are going to study this. Now only you have in the lab, I think. Am I right? R to R ladder is there, no? Analog to digital converter. DAC, digital to analog converter.
Yes, sir. It's there, sir.
Then you can will learn the design part of there. How exactly you are going to get the formula and those things. By make use of this, we are going to write some of the programs and we are going to get the output.